Hello friends, welcome to our channel. In this video, we are going to look at problem 2560, house robber 4, right? So in this video, we are going to practice binary search. So here, I think a certain level of abstraction is beneficial, right? So first, let's quickly look at the problem statement, and then we are going to explain our plan and then do the coding. And in between, we are going to emphasize several points. So here, there are several consecutive houses along a street, and each of which has some money inside. So there's a robber who wants to steal money from the homes, but he refuses to steal from adjacent homes. So this is an important assumption. Another concept that is important is the capacity. So the capacity of a robber is the maximum amount of money he steals from one house of all the houses he robbed. For example, if you look at example 1, so you can steal, the robber can steal 2 and 5, right? So then the capacity will be 5. That is the maximum amount of money he steals from one house of all houses he robbed. So that's the definition. So what we want to do is that we return the minimum capacity of the robber out of all possible ways to steal at least key houses. So that's the problem requirement. If you look at example 1, the output would be 5. And if you look at example 2, so here you can choose this, let's see, you can choose this one and this one, right? So the capacity will be 2, right? So here the constraints are the following. So the length of these knobs can be as long as 10 to the power 5. In other words, we need to pay attention to the time complexity. And this is the range of the elements, right? And here is the range of the key. It's bounded above by this number. So this is to make sure that it's always possible to steal at least key houses. So with that said, we are ready to share our plan. Our plan will be the following, right? So it's based on the 2 most important ingredients in binary search. So one is, a Boolean function. So the Boolean function is to produce order, or you can see monotonicity, right? Monotonicity. So this is to do search space shrinkage. And then after you define the Boolean function, you can determine the search space and then do search space shrinkage. Let me copy this part. So with that said, let me first write down the function of the Boolean function, and then we do the second item. So actually, you can follow up with this hint, right? So this hint basically gives us the way how to do binary search. For this problem, actually, if you have a chance to look at other videos in our playlist for the binary search, you should see that a certain level of abstraction is necessary to understand a algorithm, especially you want to understand it at a higher level, right? So here I'm not going to walk you through an example, but maybe I will do some print, but you need to be accustomed to abstract thinking. So with that said, let's first write a function. So the function will do the following. So define can rob. So here basically given a number or given a capacity. So can we rob at least the key houses so that the capacity is like this, right? So this is the here corresponding to here, right? So check function if it's possible to select key non-consecutive elements that are less than or equal to the current guess value, right? That's what we're going to do. So in order to do this, so we can initialize a count variable to be 0. And then finally, we just need to compare if this count would be greater than or equal to key, because we need to choose at least a key, right? So that's the one. So now let's, I can put it here. So the n is the length of this nums, right? So what we are going to do is this. So first I'm going to initialize a pointer that is n0. Then we are going to use while loop. While I is less than n, then we are going to check the current nums I. So if the current nums I is bounded above by this cap, meaning we can steal that, and then so the count should be incremented by 1. But in this case, we are using this one, but we cannot use the next one. Therefore, we can use I plus 1 equals I incremented by 1. So this way, if I do increment, so we are making sure that we do not steal from adjacent homes. So this way, after you finish this loop, so you can check if count is greater than or equal to k. If this is the case, we can use this up as a capacity upper bound, right? So then next, our goal is this finishes the first one, Boolean function, to yield monotonicity. This is actually very crucial. Basically, it determines the follow-up steps. But this function should be designed. So let me make a comment. So this shall be designed according to the problem logic, right? So now let's look at the second part. So let me write here, search space and shrinkage. So with the help of the can_rob function, what we want to do actually is to transform this problem to be mean capacity such that can_rob cap is true, right? This is what we want to do. So now let me do this program. So we can initialize the low and the high. So the lowest capacity will be 1, right? And the maximum one will be the max of this nums, right? So you can write a max, this nums. And then we can do the shrinkage. So here, let me do this. So while low is less than high. So in this case, we have a mid. So you notice that if cap is very large, for sure, you can make it true, right? So if it's too small, you cannot make it true. So here, what we're going to do is we do low. So we shrink half, right? High minus low, and then divided by 2. So if can_rob, let's see, can_rob mid, if this is true, right? So then we can set high equals mid. So we can still shrink. Otherwise, the mid is too small. So in this case, we are going to set mid to be low to be mid plus 1. So in this way, we can return low afterwards. So this is the full code. Now let me first test if it works. Yeah, it passes the 2 test cases. So now let's look at the generic case. Yeah, it passes all the cases. So as I mentioned, I'm not going to go into every detail. Actually, the correctness of this code can be proved by mathematical contradiction. But here, let me print out some numbers. So here, let's see, we have this mid. So we print mid, and also we print the state, right? And we also print out, let's see, we can do we can also print, but it will take some time. But let me do this. Can_rob mid. So this we called twice actually. It would be better print here, but you know it might be true or false. Let's do this. Right. So mid equals 5 is true, and mid equals 3 false, 4 false. Therefore, you have 5. And you look at example 2, right? So 5 is true, 3 is true, 2 is true, 1 is false, and you need to have at least 1. So here you have 2, so you return 2. So that's basically about it. So now you can check the term complexity. It's rather straightforward because here you do this one. This is a linear, right? Term complexity will be O of linear n, right? So here actually how many you do? So basically the term complexity will be you do logarithm high minus low times this function call, right? So basically it's O of n, right? So multiply by this one. So this should be the max of the nums minus 1. Let's just ignore this this one. Let's plus something to make sure this is at least positive. So here actually also we know that the nums is at least 1, so we can just ignore this. So this will be the term complexity for this algorithm. So with that said, I guess I finished the coding and also made several comments. So if you have difficulty to understand this logic, you can try to walk through yourself based on the print, right? So here, let me also comment out this print. So we have a playlist for binary search. I guess for now it at least 20 problems. So if you can go over all those problems, I'm sure you will get a very good understanding about the usage of binary search in the current format or using bisect module in Python. That will be very beneficial. With that said, I guess that's it for the current video. Thank you for watching.